projectile motion. You see, this is a very important aspect of motion. And it's so important because many things are construed about this motion, which by God's grace, I will be unveiling every one of them. First and foremost, well, projectile motion is the motion of an object projected at an angle either to the horizontal or to the vertical. And the part of this projectile is as shown, where you throw an object and it goes like this and then lands. Well, missiles and some other stuff are thrown in this manner. But you see, one thing about projectile motion is that people think that it's a unique type of motion that have its formula. And that's the key aspect of today's class, because projectile motion actually isn't different from other type of motion. Well, for the sake of time, I would have derived how we got the equation for motion of projectile. Let me take very few of them. First and foremost, this is the velocity of a projectile, and it is tangential to the path of motion. Now, this velocity can be resolved into horizontal and vertical. And if you followed our class of motion, actually, you will realize that we've been able to classify motion into horizontal and vertical. And so this velocity as well, very, very important to resolve this velocity into horizontal component and vertical component. If you do that, we have that u, the component of velocity along the x, is going to be u cos theta that I'm resolving along the horizontal. And if it is resolved towards the vertical, it's going to be uy, and that is u sine theta. Now, if we want to obtain the time to maximum height for a projectile, how do we do that? Now, I'm saying time taken to get to the maximum height. You see, the center of the projectile is the maximum height of the projectile. That's the highest height it attains. Now, but there's one thing we often know, that at mass height, let me say the first one, time to maximum height. Firstly, we all know that at maximum height, at max height, final velocity is 0. Actually, I'm calling this Vy because I'm talking about height, velocity at the maximum height. So anything height, I take it as vertical motion. And so we can say that Vy is equal to Uy plus At plus Gt, sorry, because if I'm dealing with vertical motion, we work with gravity. Now, mind you, we've done our Uy to be U sine theta. So we can say, and Vy is 0. So this is 0 is equal to U sine theta. And because this object is going upward, actually, this should be minus and not plus. Because if an object is going upward, it goes against gravity, so we use minus. And if it's coming down, we use plus. So this is originally minus. Please take note of that. Minus Gt. So eventually, if we make Gt, so a formula, we get it is equal to U sine theta. And then divide both sides by T to make T, so a formula, we get that T is equal to U sine theta over G. And this is how we got the time to maximum height. Another thing we can talk about here is the time of flight. I've said this often and often. The time it takes to the maximum height, from where an object is thrown to the maximum height, it's the same time it will take from the maximum height back to the same level at which it is thrown. So we can say that B, time of flight, is just time of flight, capital T, is just equal to 2 times time to maximum height. And that is 2 times U sine theta over G. And this is 2U sine theta over G. We can go on and on. Lastly, I just want to get this. I don't want to do the range, but let's talk about maximum height. max height. H mass. Already we know at max height, Vy is 0. And so we can say that V square equal to U square minus 2GH max. But since this is 0 and this is Uy, which is U sine theta, all squared minus 2GH mass. Bringing this here give us 2GH max is equal to U square, open this bracket, sine square theta. And H max become U square sine square theta over 2G. That's dividing both sides by 2G. And so this is the H mass. And that's what we have for projectile. Now, looking at all of this formula now, it is often used to solve projectile motion. But these formulas are very, very inferior to some questions, even as far as WAEC. There's some WAEC question you cannot solve with this equation. And I'll be taking questions where we can solve with this equation and the ones we cannot solve using this equation. Example 1. A projectile is fired with an initial velocity of 100 meters per second at an angle of 30 degrees with the horizontal. That has been illustrated here. This is the velocity. Now, we have to calculate the time of flight, the maximum height, and the range attained. Well, before solving this thing, I want to get my Ux and Uy first and foremost. If you're using the formula, you don't need this Ux and Uy. So our Ux is going to be 100 cos 30. And cos 30 is 0.866. So this will be 86.6 meters per second. And our Uy is 100 sine 30. Sine 30 is 0.5. And this is going to be 50 meters per second. Now, mind you, if you want to solve this question, where there are two approaches, and that is using the formulas for projectile to solve, or using your normal equation of motion. So now we solve the two methods here. First and foremost, using method 1, the formula of projectile. That's my method 1. We know that time of flight is giving us 2u sine theta over g. Now, if you are solving with this method, you are working with u, not ux or uy. So you don't need to use us or uy. Remember how we got this ux now? Resolving horizontally, that's 100 cos 30, and resolving vertically, 100 sine 30. But we don't want to do that now. We want to just use our normal equation. So your u is 100. Your u is not us or uy. It is just the u, which is 100. So you say 2 times 100 times sine 30. That's your theta over g. This will give us 10 seconds. Now, if you want to solve with method 2, using the equation of motion, all we just need to do is to say h is equal to uyt minus half gt squared. This t is our time of flight if h is 0, but h is 0. The question is, why is h 0? That's because as the object moves from here, it gains height. It gains height. This is the maximum height. By the time it falls to this part, the height has come back to 0. And when the object is here, then that's when it has covered the entire flight. So the time taken to move from here to here is what we're talking about. At this point, h is 0. So if you put your h at 0 and use your uy is 50. 50 times t minus half times 10 times t squared. Now this is equal to 50t, 2 here, and this is 5, minus 5t squared. Bringing this here, 5t squared is equal to 50t. And dividing both sides by t, we are left 5t, sorry. We are left with t being equal to 10 seconds. Now, I want to agree that this is far easier and far simple, but please hear me out. There's a reason why you should know this. And one of the reasons why I don't like this is that it helps you memorize different equation for motion. When you don't, you act rightly, you don't need that. You can use your normal equation of motion and solve your question. So why memorize new formula? But that aside, there are some questions, and we'll see that in example 2, that we cannot use our equation for projectile to solve. Only our equation of motion can get that for us. Let's take the second question. B, the maximum height attained. We still solve with the two methods again. One with the formula for projectile, that's method 1, and method 2 with our equation of motion. Well, for method 1, we have that maximum height, h mass, is giving us u square sine square theta over 2g. And so our u is giving us, this is your u, please mind you. U doesn't mean us or uy. That will be 100 square sine square 30 over 2 times 10. If we do this accurately, we would have our h mass to be 125 meters. Now, if we use that method 2, we use vy square minus, is equal to uy square minus 2gh. Now, using vy and uy, because we're looking for maximum height. And height is the vertical motion, so you use vy and uy. But remember, at maximum height now, vy is equal to 0. So this will be 0 square minus equal to, your uy is given as 50. So this is 50 square minus 2 times 10 times h mass. So obviously we have 2500 minus 20 h mass equal to 0. So now we have 20 h mass. If you bring this to the other side of the equation, is equal to 25. And then h mass is equal to 2500 over 20. And that's still 125. Now understand, we still give it to our formula method because we still got the same answer. And we stick to equation of motion. We didn't learn any new equation. It's possible to forget any of this equation. But that's not just the advantage. Like I said, there are questions we cannot solve with this. Lastly, the range. For the range, our equation of motion is a faster method actually. And you will see why I say that. Now, for your range, our formula is range is equal to u square sine 2 theta over g. And so you can say r is equal to u 100 square sine times sine 2 times 30 over g 10. If you do that, you get 866 meters. Well, for our range is an horizontal motion. And we can say x is equal to u xt minus half 80 squared. Now I'm using x because range is an horizontal motion. So this is the horizontal distance. That's range for you. One thing you need to note that since this object is thrown, a is 0. I said it before that whenever you throw an object, the acceleration is 0. An object thrown can never accelerate. So a is 0. So we're left with x is equal to ux times t. And what is t? T is the time of flight because range is from here to here. And time taken from here to here is the time of flight. We've gotten our time of flight to be 10 before. So this is simply s is equal to 86.6. That's our ux times time t 10. And this is 86 meters. Faster than this actually with this formula. Faster than this. So that's that about that. Our equation of motion still gives us the same answer. But let's move to example 2. And these are questions sometimes we've met in WAEC. Example 2. A stone is projected at an angle of 40 degrees to the vertical with an initial velocity of 50 meters per second. Calculate its height after 3 seconds. This is a very straightforward question and just require you to get one thing, the height after 3 seconds. Well, to begin with, this is the projectile. Projected with a velocity of 50 meters per second, making an angle of 40 degrees to the vertical. And so you must get the angle it makes with the horizontal. And that will be 90 minus 40. That's 50 degrees. So mind you, you must use the angle it makes with the horizontal. But that's not the most important thing about this question. Is how to get it. Now, at this point in time, every of our equation on projectile fails. Because what we have for height is the maximum height. We don't have the height for any time, for 30 seconds or for 4 seconds or for whatsoever. So no equation of motion for projectile can solve this. But our normal equation for motion can do this for you. Now, first of all, what's your ux and your uy? Well, because we are asked to get the height, we need only uy, we don't need ux. Our uy will be 50 sine 50. And that will be 38.3 meters. And so, per seconds, please. Okay, you can go and get ux, but you don't need that. Now, all you just need to do is to say h is equal to uyt minus half gt squared. And you're going to get your answer. What's your uy? We've done that. 38.3 multiplied by the time 3 minus half times g is 10 times 3 squared. Here, this will give us 38.3 times 3. 114.9 minus 2 year 1, 2 year 5. 5 times 9, that's 45. So, minus 45. This is 69.9 meters. Quite an easy question that we cannot get with our equation of projectile. And that's what I'm talking about. Let's take example 3. And that question on projectile that we cannot solve with our equation for projectile. Example 3. This is WAEC 2022 major question, theory number 1. Now, if you've read motion with any of your conventional secondary school textbook, I'm sure you will not be able to solve this question. Many students got this question wrong. This is actually a projectile question. And that's why I will often say that it's not often good to stick to the formulas of projectiles, such as maximum height, time of flight, time to maximum height, range, or maximum range. Every of those formulas given to you would fail for this question. Now pay close attention. Let us solve this question. One of the first things to do in solving this question, let's look at the question first. The diagram above illustrates the trajectory of a fired missile from point P at 250 meters per second. If the missile hits point Q after 10 seconds, that's a mistake, please. After 40 seconds, calculate the distance PQ. Now, to solve this question, all we simply need to do is to get what we call our ux and uy. Now, well, we will only be using ux, but still pay close attention now. To get ux is to resolve this vector, this velocity, horizontally. A velocity is a vector, so I hope you understand. Resolving this horizontally. Now, if you don't know how to do that, I will drop a link to our video on resolution of vector, and easily you can solve that. So just resolving this horizontally, and that will simply be 250 cos 42 degree, and that will give us, this is 185.79 meter per second. And you can get uy, which is 250 sine 42. Although we don't need this actually. But that simply means resolving this vertically. That's uy. And that will give us 167.28 meter per second. But we don't need this. Now, and there's a reason why we don't need it. Now let's solve this question. All you just need to do is to use your horizontal velocity equation because I'm looking for an horizontal distance. So simply say x is what this equation we're using equal to uxt plus half at squared. This x means horizontal distance, and that's the distance pq. In this question, we are given time to be 40 seconds. And so what we simply do here now is to use our ux. But remember that once an object is thrown, that object cannot accelerate. A thrown object cannot accelerate actually. And so our a is 0. So everything here becomes 0. So we are left with pq, which is our x, being equal to our ux is 185.79 multiplied by the time, 40 seconds. And that will simply give us this 7,431.6 meters. That's the distance PQ. Actually, last year, many students went to use the range equation that says range is u squared sine 2 theta over 2g. And that was wrong because you are given time here. So I will often say that for every kind of motion you want to solve, you can actually use your equation of motion. And I categorize motion in my video into horizontal and vertical motion so that you can have proper understanding of what category the motion falls into the equation you want to solve, and then solve it using the equation of motion, knowing when to resolve horizontally and then vertically. So go to our description, you will get a link on our motion video. Every type of motion, motion under gravity, linear motion, rectilinear motion, horizontally projected motion, and then projectile. Example 4. This is another past question from WAEC, May, June. And like I would often say, this is another question that the equation for motion for projectile fails to answer. Now, we're going to answer this question briefly, showing you clearly how you can answer this question. Now, let's illustrate the path of a projectile firstly. And then this is the velocity tangential to the path of motion, make an angle of theta to the horizontal, as the question says. With a velocity u, and that's what we have here now. Okay, so firstly, let's go and get our horizontal component of u. That will be u cos theta, because resolving to the horizontal. And resolving to the vertical, that will be u sine theta. Okay, the first one says that we should prove that horizontal component of velocity, actually this is talking about the final velocity because we already have the initial velocity. That's Vx and Vy. Here is Vx, horizontal component, I call it Vx. And so Vx is equal to, we know, Ux plus At. But just like I've often said, that once an object is thrown, the A is 0. As long as it's a projected object, A is 0. So therefore, your Vx is equal to, Ux is given as u cos theta plus A, which is 0, times T. Eventually, this goes off. And we are left with Vx being u cos theta. As we look at this equation now, there is no T in it. So the horizontal component of velocity does not have T, so it's independent. Since it does not have T, you say it's independent of T. Now let's take the vertical component. It will be given as Vy is equal to Uy, then minus Gt. Minus because the object will first of all move upward. That's why it's minus. Now, from here now, we can say our Uy, this is number 2. Uy is given as, Vy is given as, our Uy is given as u sine theta minus Gt. Now, this is dependent on T because the equation has T in it. So, the vertical component of velocity is dependent on time since it has t in it.